All right. Hi everyone. Yeah, sorry, my iPad had gotten switched off and I had to charge it before I could start the class. All right. So first of all, welcome to Unacademy JEE English. This is a brand new channel by Unacademy where everything is taught to you completely in English. All right. Next, this is a series that I conduct for class 12 students, and this is lecture 6 of Capacitors. And today we're going to talk about RC circuits. Now, before we move forward, let me introduce myself for one more time for those of you who don't know me. All right. So, my name is Rohit Dixit. I studied mechanical engineering from IIT Delhi, and for the past 7 years, I have been teaching physics for IIT JEE. And I myself was JEE rank 447. All right. And I've already coached many students to top ranks in IIT JEE. Next. So as I said, all my past teaching experience has been in offline setup. So this is the first time I'm teaching online, courtesy Unacademy. So it's worth mentioning that you guys can also make the most of the Unacademy for your online studies with your Unacademy subscription. All right. So how do you do that? You can get this subscription which has benefits like live classes. You get to interact with your educators. You have live polls and leaderboards. You have test series and analysis, and you have live doubt clearing sessions. Trust me, all these plus features, they give your online classroom uh, a very great experience, very close to your offline setups, and they help you prepare for your JEE exam to the best with the help of these test series and live doubt clearing sessions. All right. Now, plus, along with all these benefits, the best feature would be that you're getting access to India's best educators. So, all top educators have been brought by an academy on a single platform so that you know you don't have any confusion as to who to study from. All right. Next. So, how do you get this subscription? It's very easy. So, all you need to do is install this app. Once you have done that, go to the plus section, select your goal as IITJ, and click on get subscription. All right. Now, please note that these prices are going to get hiked. So, these prices are valid only till 10th of September. So if you haven't gotten your subscriptions yet, please, I would advise you to hurry up and get them as soon as possible because these prices, you can only get your subscription at these prices till 10th of September. After that, the subscription fee is going to get hiked and that hike will be significant. Alright. So please remember to get your subscriptions as soon as possible. Alright. And you can always use this code RD Live. This is my code if you want to, study for me. If you want to enroll in my courses or the class, then you can use this code and get your subscriptions. This will also give you a 10% off, irrespective of whether it's the new fees or the later fees. All right. Now, for those of you who are following us on the JEE English channel, you can connect with us on the JEE English on the Telegram app using this link shown here. All right. Next. So why don't we start with today's topic, which is capacitors with dielectrics, and today we are also going to talk about RC circuits. All right. So we started this discussion in the last class. Oh, hello AP. How are you? Good to see you. So we started this discussion in the last class where we were talking about what will happen if, what are dielectrics, how do they behave, and why do they behave the way they do, and what do we do when our capacitors are filled with dielectrics. All right, so we went over some formulae. We realized if there is a dielectric of dielectric constant K, what that does is it increases your increases your capacitance by a factor of K. So in such a case, the capacitance would become K times epsilon naught A over D. And if this was filling it partially, so okay, we discussed this. Similarly, we also discussed the magnitude of induced charges. So we realized that there are some charges which get induced on the dielectric surface. These were called bound charges. The magnitude of these bound charges is given as Q times 1 minus 1 over K, where Q is the charge which is here, which is the free charge, all right, on the metal plates of the capacitor, all right. So remember that. Next, we also talked about partially filled capacitors, which are partially filled with dielectrics, and I told you that the formula for this would be that C would be epsilon naught A over If you had multiple dielectrics of different dielectric constants, then T1 over K1 plus T2 over K2 and so on. Alright, this would be the formula for a capacitor filled with multiple dielectrics. Alright, so please remember this is important. Alright. Next, okay, so I also told you that in case you have air, so you realize for any gap of air, you can think of that as a dielectric of dielectric constant 1. So again, you can use this formula. In this formula, the thickness of air or vacuum can also be put with along with 1 in the denominator. Alright, so please remember that. In case you have metal, in case you're keeping a piece of metal inside, then for metal, your K would become infinite. Alright. So please remember for air or vacuum. Alright, your K is 1. For metals, you can consider the K to be infinite. Alright, and for any other dielectric, you will put the dielectric constant of that. Alright. Now, I had also told you that the dielectric, what that does is it reduces the field actually by a factor of K. Alright, and that is why in Coulomb's law, everything was depending on the dielectric constant of the medium around. Alright, every force would get reduced by a factor of K. Alright, if there is a dielectric medium present. Alright, so please remember that. Next, we wanted to go over some problems. Okay, so I think we already tried this. I wanted to show you some more problems. So suppose there is this problem. So it says a capacitor stores 50 microcoulombs charge when connected with a battery. When the gap between the plates is filled with a dielectric, the charge of an additional charge of 100 microcoulomb flows through the battery. Alright, so you have to find the dielectric constant of the metal inserted. So why don't you guys try it? So let's try and answer this one. Alright. So let's try and solve and quickly answer this one. Alright. While you guys take a look at this, maybe I'll just grab some water quickly. Alright, so try and solve this quickly. So till the time I get some water. Okay. Alright. So, okay. So, strange enough, you guys are not participating as usual. Alright, it's fine. It's fine. So, why don't I go ahead and solve this? So, what does the question say? The question says that a capacitor is storing 50 microcoulombs of charge. Now, when it is connected across a battery, if the gap is now filled with a dielectric, a charge of 100 microcoulombs flows through the battery. Alright. So, what does that mean? So let's say if it was connected to a battery, let's say its initial capacitance was C0 and you connect it to a battery and it gets some Q initial. Alright, so I know that Q initial would be C0 times V. Finally, when you insert this gap with a dielectric of dielectric constant K, now what happens? Now you will get a Q final. And this Q final, remember, would be, now you filled it with dielectric. So if the dielectric constant of the dielectric that you filled with is K, this capacitance would become K times C0. Alright, so now you can say that the final charge, Q final, would be K times C0 times V. Alright, and next what were you told? You were told that an additional charge of 100 microcoulombs flows through the battery. Alright, so all you know is that Q initial is 50 microcoulombs. And what would be Q final? Q final would be 150 microcoulombs. Alright. Why? Because an additional charge of 100 microcoulombs had flown. Now all you need to do is divide these equations. So when you divide ththese equations, you will realize Q final over Q initial would be equal to K, which is essentially 3. So that is what your answer is going to be. The dielectric constant of the dielectric that you're looking to find is 3. Alright. Okay, so we also talked about dielectric breakdown last time, if you remember. So we realized that when the electric field across a dielectric is increased beyond a point, if you go on increasing the field, there will come a point when, why are the electrons of any dielectric or any material for that matter bound to their nuclei? So we discussed, in case of conductors, the outermost electrons are loosely bound, but in case of insulators or dielectrics, they are not loosely bound. They are very tightly held by the nuclei. Alright, they cannot leave their orbits. However, see, the force that is holding them to their orbits is the attractive force of the positively charged nucleus. Alright, so your nucleus has a positive charge. Alright, so let's draw this. So this has positive charges. Your electrons are negatively charged. So it is the electrostatic force of the positive nuclei that is holding these negative electrons in their orbits. Alright. Now imagine what happens if I switch on an external field. Now if I switch on an external field, now this external field would try and apply a force like this on electrons. Alright. So what this does is this is trying to pull the electrons out of their orbits. So imagine what will happen if I keep on increasing the field. If I keep on increasing the field, then this force that the electrons are feeling, that pull due to the electric field, at one point in time, it may become higher than the pull they feel due to the nucleus. When that situation comes, then you will see that these electrons will start leaving their orbits. And once they start leaving their orbits, now they are not bound to the nuclei anymore. And they are experiencing such a high force that no nucleus will be able to stop them further also. Alright, so you realize that these electrons will now become free electrons and they will start flowing and cause the conduction of electricity. Alright, so once this happens, all these electrons, they are free from their respective nuclei, they can start flowing and they cause the conduction of electricity. And due to high resistance of dielectrics, generally this process produces a lot of heat, a huge amount of heat, which essentially would damage the dielectric also, and that is what you call dielectric breakdown. I've given you an example that lightning is nothing but the breakdown of air. Alright, so here is a question on that. So this question says a parallel plate capacitor is formed by two plates, each of area 100 centimeters square. They are separated by a distance of 1 millimeter. Alright, a dielectric constant 5 and dielectric strength. So this is the dielectric strength. What dielectric strength means, this is the maximum. This is the maximum electric field to which you can subject it without causing the dielectric breakdown. So let me maybe write it here. Dielectric strength. So let's make a quick note of that here. All right. Okay. So dielectric strength. Now dielectric strength may be given to you in two ways. Either you may be given the strength of the electric field, or you may be given the maximum potential difference across the dielectric. So dielectric breakdown potential. All right. So dielectric strength. This is the. It is the maximum. It is the maximum electric field. It is the maximum electric field to which the dielectric can be subjected. To which the dielectric can be subjected without causing its breakdown. Alright, so please remember that. That is what dielectric strength is. Similarly, you may have something called a breakdown potential. Breakdown potential, on the other hand, hi Chandrasekhar, good afternoon to you as well. Breakdown potential may be the highest potential difference that you can apply across a dielectric before you cause the dielectric breakdown. So it's a very similar thing as dielectric strength. It's just that sometimes you talk about the highest amount of field that you can apply, sometimes you talk about the highest amount of potential that can be applied. Alright. So here you have been given the dielectric strength. You realize from the units that this is the strength of electric field. Alright. So you have been told that your material has a dielectric constant of 5 and dielectric strength of 1.9 into 10 to the power 7 volt per meter. Alright, this is filling the place of the capacitor. Now you have to find the maximum charge that can be stored in the capacitor without damaging the dielectric. Alright, so would you like to try this? Good evening, Prinkle. How are you? So Chandrasekhar, why don't you try this? Alright, so let's give this a try and let's see if you guys can solve this. Okay. So this should be easy. This should be easy. You know the field that a capacitor would create. So this is, by the way, the external field. This is supposed to be the external field. Alright, the maximum external field in which you can put a dielectric without causing its breakdown. So try and solve this. So what do you think would be the maximum charge that you can give to this capacitor without damaging the dielectric? Alright. So let's wait for 2 minutes. Hi Harsh, how are you? So Harsh, why don't you give this problem a try? Let's see if you can solve this. What class are you in, Harsh, by the way? By the way, you guys can always write trying in the chat so that I get to know that you are trying. Alright. So you wanna give this problem a try? Alright. So class 12th. So then you can definitely give this problem a try, right? Alright, Harsh. Have you studied your capacitors already? Okay. So please let me know if you're trying. Just make the effort of writing, trying in the chat. I know you guys feel lazy to write that. Alright. Actually, I have to start. Okay. So what you can do, Harsh, is that I am hosting this series, alright, every Tuesday, Thursday, and Saturday for class 12 students, wherein I have started. I started from electrostatics. I'm still continuing with electrostatics. So I've taken every topic one by one. So what are fields? What is Coulomb's law? How to apply Coulomb's law? What is Gauss theorem? What are the application of Gauss theorem? And everything. Everything I've discussed from the basics. So what you can do is you can start watching my videos, alright, class 12 videos, and you can then attend my series, this series that I host every Tuesday, Thursday, and Saturday. Alright. So why don't I solve this problem in that case? So let's see what were you told. You were told that the capacitor is formed such that the area of the two plates. So you've been told area is 100 centimeter square. Alright, separated by a distance of 1 mm. So d, small d for the capacitor is 1 mm. So let's always write the key information. Alright. Now you've been told that it has a dielectric inserted in it, which has dielectric constant of 5. So dielectric constant of K equals 5. And then you have the breakdown E. E breakdown as 1.9 into 10 to the power 7 volt per meter. Alright. So once you have all this information, you have to find the maximum charge that can be stored in the capacitor. Alright. So now let's see. Now let's see what is happening. So the charge Q, let's see. So let's say I've given it a charge Q. Now you will realize, okay, so if the dielectric is given a charge Q, if the dielectric is given a charge Q, now what happens? Now you will realize that the potential difference across the plates would be V equals Q over C. Alright. And if the potential difference is this, then the electric field, higher for education, then the electric field would be V over D. Alright. I hope you remember this. And what you want is you want that E should be less than equal to 1.9 into 10 to the power of 7. Alright. So that is all you have to do to find the maximum charge that you can store here. So let's start substituting the values. So that will give me Q over C times D should be less than equal to 1.9 into 10 to the power 7. Now Q should be less than equal to 1.9 into 10 to the power 7 into C, which is epsilon naught A by D into K into D. Alright. Okay for education. So I will look at that and give you the answer as soon as I can. Okay. Don't worry about it. Alright, so please I hope everybody is following this, what we are doing here. Okay, so the net is fluctuating a bit, so you'll have to bear with me. Alright. So this is how you will go about solving the problem. Alright. Now it's nothing, you substitute these values and you'll get your answer. Alright. All you need to do is substitute these values. So what you can do is multiply divided by 4 pi. Now you'll have, okay, so 1 by 9 into 10 to the power 9 into 4 pi into area. Area was 100 into 10 to the power of minus 4 into the dielectric constant K5. So this is what you will have your answer as. Alright, please go through this and let me know if you have a problem with this. If you followed this, well and good. If there is any part that you did not follow, then let me know. Alright. So what you're doing is that you're assuming that we are giving it a charge Q. Based on that charge, we are finding the electric field that the dielectric is subjected to. Alright. So let's hope everybody got this. And then we are using this condition that this electric field should be less than equal to the breakdown field. Alright. Okay. So quickly go through this. And if you understood this, then we can move ahead. If not, then you can let me know in the chat. Alright. So I guess, yeah, this was simple enough. Alright, now you will get some tricky cases of, capacitors filled with dielectrics where you will be asked to find the net capacitance. Alright, so here are two cases of such. Alright, so in the first case, it says a parallel plate capacitor with no dielectric has a capacitance of 0.5 microfarad. Alright, the space between the plates is then filled with equal amounts of two dielectrics of dielectric constants 2 and 3. Alright, in two arrangements as shown one by one. So in one case, the two dielectrics fill the space like this. Alright, so they are covering half areas like this, and in the other, it is filled like this. Now, what will be if the two capacitances are C1 and C2? You have to find the ratio of C1 is to C2. So now, how do we solve this? Alright, so this is a tricky part, so I will solve this for you. and I will show you how to tackle this. So you were told, yeah, the dielectric constants were 2 and 3. So in the first case, what you will realize is, alright, so this has a dielectric constant of 2, this has a dielectric constant of 3. Alright, so let's mark them with different colors. So this green one has a dielectric constant of 2. Alright. And let's assign some other color to the other one. Let's say this is orange. The orange one has dielectric constant of 3. Alright. So now all you need to do is remember this, that you can think of this as a parallel combination of two capacitors. Think about it. If you just focus on the first half, let's say if I'm just focusing on this part. So this is a capacitor which is fully filled with a dielectric of capacitance, dielectric constant 2. The area of cross section of this entire thing, if this distance is d, so area, if this area was, total area was A, then this area would be A by 2, right? Why? Because you've been told that both the dielectrics are filling the space equally. So then now you can think of this as one capacitor, alright, which has area A by 2, distance d, and it has a dielectric inside it with dielectric constant 2. Similarly, you can consider this as another capacitor. Alright, so you have essentially have two capacitors, and these two capacitors, please mind it, will be connected in parallel. Why? Because this entire capacitor plate will have a potential of V1. This entire capacitor plate would have some potential V2. You realize capacitor plates are metals. Metals always have the same potential. So this one is connected between a potential difference of V1 and V2. So is this one. So you can consider this as two capacitors connected in parallel with each other. Alright, so the equivalent of this would be, you make two capacitors, alright, which are connected in parallel. So here is V1, here is V2, and this guy was filled with the orange dielectric, and this guy was filled with the green dielectric. This is what the situation is. Alright, now it should be very, very easy. So if this was C1 dash, this was C2 dash, then the net capacitance would be C1, in this case it was C1, would be C1 dash plus C2 dash, which is equal to, what will be the value, individual value of C1 dash? C1 dash would be epsilon naught, okay, so let's rewrite that. Epsilon naught A by 2D times K1, which is 2. Alright. Plus the other one would be epsilon naught A by 2D into 3. So what you have is 5 epsilon naught A by 2D. This is the capacitance of this, what you see here. Alright. And this, okay, this also you can write. You have been told that the parallel plate capacitor with no dielectric has a capacitance of 0.5. Alright. So you also know, you should know that epsilon naught A by D. So if this was not filled with any dielectric, then this entire capacitor should have had a capacitance of epsilon naught A over D. This was given to you as 0.5 microfarad. Alright. So this term is nothing but 2.5 times this. So what will be 2.5 times this? Okay, so that will be 1.25. So C1 is 1.25 microfarad. Alright, that is what the capacitance of this will look like. Now, let's consider the other one. Now, what can you say here? What can you say here? Here, this is nothing but a series combination of two. Alright, I hope you can realize that. If the potential here is V1, if the potential here is V2, and the potential here is some V3. Alright, you realize in this entire matter, here the electric field would be 1. So everywhere the potential difference would be created the same. Alright, so every point on this line would have some potential of V3. Alright, so now what you can do is you can think of this as two capacitors which are in series with each other. Alright, one capacitor which has a distance small d which is reduced to d by 2. The area is A. It is filled with dielectric of dielectric constant 2. Alright, so let's draw that. How is that looking to be? So here you have an arrangement like this. Alright. So the upper half is filled with dielectric of dielectric constant 2. The lower half is filled with dielectric of dielectric constant 3. Alright. So here you have dielectric constant 2, here you have dielectric constant 3. This becomes d by 2. This also d by 2. The area of cross section for both the dielectrics would remain A. Alright, so please remember this. Now there is nothing. This is a series combination. So I can now write this. If this is C1 double dash, this is C2 double dash, then I can write my C2 as, okay. So let's see what. Alright, here we have it. So C2 would be C1 double dash, C2 double dash over C1 plus C2. This is the formula for series combination. Please remember this. Alright, okay, so let me just write it again. Let me write it slightly bigger. So C2 would be C1 double dash, C2 double dash over C1 double dash plus C2 double dash. Alright. Now, how can I write these two C1 double dash and C2 double dash? From here I will see that C1 double dash is nothing but epsilon naught A over d by 2. So this becomes this into the dielectric constant 2. Similarly, C2 double dash is again similarly 2 epsilon naught A over d into the dielectric constant 3. Alright, so this is what my C1 and C2 double dash are. Alright. So now this is easy. When you're multiplying this, what do you have? What do you have your C2 as? Your C2 would be, okay, so 4 into 6, okay, so 4 into 6 into epsilon naught A by d whole squared. Alright, so that is what I'm getting when I multiply this. Alright, 4 into 6 into epsilon naught A by d whole squared. Next, what I do is I divide it by C1 dash plus C2 dash. So what is C1 dash plus C2 dash? So that is 4, 4 plus 6, that is 10. So divided by 1 by 10 epsilon naught A over d. So you realize one of this would get cancelled with this. This gets like this. So what am I getting? I'm getting 12 by 5 epsilon naught A over d. Alright. So this is what I'm getting. Now you will also remember that epsilon naught A by d, we had already discussed this, was 0.5. Alright. That had been given to you here. So now if I substitute that value here, what am I getting? Let's see. So C2 turns out, C2 is 12 by 5 into 0.5. So it is 1.2. Alright. Now it's very easy. You have to find the ratio of C1 is to C2. Now you can do that. It will be 125 over 120. Good evening, DK the Prodigy. How are you? So C1 is to C2 now becomes 1.25 is to 1.2. That will be your answer. Alright. So please let me know if you followed this. Just remember that in the first one, you can consider this a parallel combination of two capacitors. Similarly, this can be considered as a series combination of two capacitors. You find the individual capacitances. Alright, and then you add them in either parallel combination or series combination, and you will have your final answer. Alright. Now, this is a trickier one. Alright. So, how do you get the capacitance of this? In this, you have been told a capacitor is formed by two square metal plates of edge A each, separated by a distance d. The dielectrics of dielectric constants K1 and K2 are filled in the gap as shown in the figure. You'd find the capacitance of this arrangement. How is a capacitor charged? So it is usually charged by connecting to a battery. It is charged by connecting to a battery. How else will you charge it? You generally connect it to a battery. Okay. See, you don't need to give a net charge to a capacitor, right? The two plates of a capacitor will always have net zero charge. All you need to do is transfer this charge of plus Q from here to here. If you can do that, then they will automatically have these charges. And that is what a battery does. You connect the capacitor to a battery, and that battery transfers some charge from here to here. Okay? Alright. So why don't we try this problem then? Why don't you try this problem? This is a super tricky problem. I think this is a problem in your HC Verma, and this is one of the problems which most students can't solve. In my experience, in all the years of my teaching, I think every student has struggled with this. This is one problem that students just can't seem to solve. So why don't you guys give it a try? I'll give you 2 minutes. Okay, Soham. So good. That is good. Good for you. But I still wanted to discuss this because a lot of students have a tough time solving this one. If you solve this, then very good. Because very few people can solve this. Alright. So I just wanted to discuss the solution of this so that for all the students who face a tough time solving this can now know how to solve this. Alright, so I will be showing the solution. Okay. So yeah, it's going to be lengthy, it's going to be tricky, so why don't I do it? Alright. In any case, I wanted to show you the solution, so in any case, I will be discussing it. So now, how do I solve this? Yeah, I know. I was also thinking that. So let's see. Alright, so this is what the situation has given to me. Let's just fill it with two dielectrics. So one dielectric is here. Alright. And another is filling up. This one. Alright. So now let's see what has been told. So you have been told that the distance between the two plates is d, and the plates are squares of edge A each. Okay. So now all I need to know is, okay, so yeah, I know, answer is also too big. So this is K1, this is K2, this is a square plate of A, this, and it would probably have another dimension like this, and that would also be A. So this is what your plates are looking like. The plates are actually squares. Alright, the plates are squares of A by A each, and this distance is D. Now what you do is that you realize that at every point, this capacitor has different amounts of dielectrics filled in it. So what you do is you consider a portion which is x distance away from here, alright, and which has a thickness of dx. So that is what you do. You consider a portion of thickness dx which is at a distance x. Alright, so let's do that. So this is dx. Alright, so this small thickness is dx. Now look at that. It had some part filled with K1, some part filled with K2. And what can I say? What can I say if I break my capacitor into combination of or different such parts? You realize this part and this part and this part, all of them have the same potential difference across them, right? Because they are all connected with the same identical two plates. So which means I can consider every part of this to be in parallel. I hope you realize that I can consider every part of that to be in parallel. So now I know 1 over C equivalent. 1 over C equivalent would be summation of 1 over Ci. And in this case, since I'm taking continuous values, so 1 over C equivalent would actually be, so in this particular case, I can say 1 over C equivalent would be integral of 1 over small c's. Okay. Yes. So now let's just solve this also. The solving is also very complicated. Alright. Now here, you imagine that this angle is theta and this is y. Alright. So now look at different triangles. So look at triangle, let's call this A. Okay, so let's not call this capital A because capital A we generally use for area. So okay, not to confuse anyone, let's stick to different symbols. So let's call this P, this Q, this R, and this S. Alright. So now let's take a look at this T. So let's take a look at triangle PQR. If you look at triangle PQR, what do you see? Tan theta is equal to D over A. Alright. Tan theta is equal to D over A. I am sure you can see that. This is D. Right. This is D. This was A. This entire thing was A. So tan theta would become D over A. Now if you look at triangle PST. Now what do you see? You see tan theta equals y over x. So from the two equations, I can say y equals x d over a. Alright. Now let's remember the formula. So what will be the small c? The small c for this little part. So small c for this little part would be epsilon naught into small area of this. So dA over you will have this thickness over K1 plus y over K1. So d minus y over K1 plus y over K2. Alright, I hope you remember this. Okay. So here I've written something wrong. This is not this because these are parallel. So you will simply add them. Integral of all DCs. Alright, you will simply add them because this is parallel. Sir, does this elemental dx also have volume? Of course, this will have volume. Yes, this will have volume. Okay. So all I need to do is, this is my DC. Alright, so all I need to do is integrate this. So I will know that C equivalent, alright, C equivalent would be equal to epsilon naught. I can write dA. dA is the area of this. dA is nothing but this area, by the way. This is what dA is. dA is the area of this plate. Alright, so you realize this is dx. This length would be A. So the area of cross section, right, area of my plate, small area of my plate, which is in which this capacitor is formed, is small a times dx. So dA becomes small a times dx over d minus y. Again, d minus y. Instead of y, I will write x d over a. The entire thing divided by k1 plus y again x d by a by k2. Okay. Alright, I hope you can figure this out. So now you have to integrate this, and what will be the limits of x? X will go from 0 to small a, right? So initially x will start from here, so that will be 0. When x reaches here, x will be equal to a. Alright, so this is all you needed to do. This is all you needed to do. That is why this question is so tough. That is why a lot of students have trouble with this question. So let's see. I will take a times k1 k2 as the denominator. Then I have epsilon naught a square k1 k2 dx. This is what I am getting in numerator. And let's talk about the denominator. In the denominator, you will have k2 ad minus xd and plus k1 xd. Alright, just solve this, you will get this. So 0 to a. Now, all you need to do is integrate this. That is all you need to do. Integrate this small little expression. So this would be integral of 0 to a epsilon naught a square k1 k2 over. Now here I'll take all the x's together. If I take all the x's together, let's see what I get. I get a dk2 plus xd I can take common, and then I'll have k1 minus k2 plus xd common, k1 minus k2. Now you realize the integral of this will be in log. Okay, so here is this also. So now you just integrate this using log. So you will get integral of this would be, you take all the constants outside. So this will be coming outside. If you integrate this, you will have 1 over d times k1 minus k2, and inside you will have ln of a d k2 plus x d k1 minus k2. Again, limits going from 0 to a. Yes, it is tricky, prodigy. Now, when you're putting the limits, when you put it as 0, you will have a d k2. When you put it as a, then you realize a d k2 will get cancelled and you will have a d k1. So when you put the limits, you will get k2 over k1. Alright, so once you put the limits, your final answer would be, okay, so let's see. Everything here will remain like this. So epsilon naught a square k1 k2 over d k1 minus k2 into ln of k2 over k1. This is what you are getting when you solve this, when you put the limits in. Alright. Now this is such a lengthy and exhausting question that sometimes even I'm not sure if I've done it correctly. So maybe why don't we check it if I have the book with me. I would always like to check such a lengthy calculation because you never know where you may go wrong. Okay, so where is the book? I can't seem to find it. See or not. Alright, never mind. So let's just trust that I have not made any mistake. Let's just have that faith. Alright. So this is the answer that you should be getting. And you can check it in your HC Vermas, and if my answer is different, then you will have to check my calculations. Because this is such a lengthy problem that it is very likely that somewhere I could have written something wrong. Alright. I hopefully didn't. I don't think I did. But still, it's always better to check the answers and recheck your calculations. Yeah, even I think definitely the answer was something like this only. Alright, so let's move forward. Now, what about the energy stored in the capacitors with the dielectrics? So, in presence of dielectrics, you realize that V across the plates increases for the same Q. So, if imagine I had a charged capacitor, and if I'm putting in a dielectric, what is happening to its energy? What happens to its energy? So, I know energy stored U would be half Q square over C. So you realize half Q does not change over K times C, or if this is C naught, so you will have K times C naught. So you realize the moment you are inserting a dielectric. Okay, so I have disconnected this to a battery, by the way. I have not connected this to a battery. So I have a dielectric which was charged earlier to a charge plus Q minus Q. Now I insert a dielectric. Of course, that will not change the charge here. Alright, because the battery is not connected, so charge conservation will have to hold. The charge cannot change. Alright, so I will realize that what is happening to the energy is suddenly decreasing the moment I insert this dielectric. Why is so? Where did the energy go? Where did this energy go? Alright, what do you think happened to this energy? When I inserted the dielectric, why is the energy getting reduced by a factor of K? Where is it going? Alright, any guesses? So what do you think, DK the prodigy? Where do you think this energy is going? The moment I insert the dielectric, the energy seems to be getting reduced. Earlier, the energy stored was Q square by 2 C naught. Now it becomes Q square by C naught K. Work done. Work done where? Work done where? Work done where? Okay, I will tell you an interesting thing. Yes, Shibrawat. I know PUBG ban. Alright. Yes. But if you are a serious IIT aspirant, I don't think you should be worrying about that. It's good, you have one less distraction to worry about. So let me tell you one very interesting thing. What happens is, if you have this capacitor and if you got a dielectric, turns out this capacitor will pull the dielectric inside. So you don't have to do work actually. You don't have to do work. It'll simply pull it. It'll simply pull it. Which charges are moving? Which charges are moving? Okay, can we can we put a stop to the PUBG discussion for now? Not during lectures. Alright. How are you, Noman? So we will talk about this later. We will talk about this later. When you're actually putting the dielectric, and if you leave it, the plates would actually suck the dielectric into it, and this dielectric actually substance would gain a kinetic energy. So this stored energy that you see, alright, this will get into the kinetic energy of this, and there is also polarization happening. So there is where you can say the energy got spent. Alright. Okay, so I will talk about that in detail. In detail, what happens if you have capacitor plates and if you put a dielectric slightly, the capacitor plates will pull the dielectric in. No, Sohan, I have not got hold of the mains paper yet. I will talk to the team after this. I had requested them to provide me with a paper as soon as possible. I still haven't gotten it. So we will talk about this later. This is a case on which a lot of questions are asked. You put a dielectric slightly inside the plates and then it gets sucked. It feels a force, and because of which it accelerates, it gains a kinetic energy. So the energy that you're seeing here, which is this the stored energy that is getting lost, it will actually go into the kinetic energy of this, and we also call it part of polarization energy. All right. So in any case, now there are two ways in which you can insert a dielectric in a charged capacitor. So imagine there was a charged capacitor and you inserted a dielectric in a charged capacitor. You will have a lot of questions over this. So there are two conditions. One is if the battery was still connected. So in this case, what will happen is if you still had this connected to a battery, imagine. So you have this and now you are inserting this. So even if you're inserting the dielectric, you realize that the potential difference across the plates will not change. So the potential difference across the plates in this case would still remain V. So please remember this. In this case, the V across the plates, the delta V across the plates does not change. Why? Because that is the role of battery. Battery will maintain that potential difference across plates, does not change. So it remains V. It remains V. So what will change? What will change? Capacitance, of course, will change. If you are inserting a dielectric of dielectric constant K, so the capacitance obviously would change. Alright. So capacitance increases by a factor of K. Now please remember, this is very, very important. This is asked in your boards also. Will JEE 2021 be postponed? I think they may just skip the January session, but I don't think they would want to postpone it beyond the April. All right. Maybe they can have it quickly in April and May or something like that. See, the problem is that a lot of classes are not happening now that they have started classes for. I think they are planning to start classes for class ninth students onwards from 31st from 21st of September. So I don't know if the boards will get delayed. So it all depends on the boards also. All right. I think it may get delayed, but in any case, as I keep telling you guys, do not rely on things to get delayed. Just be prepared for the worst. All right. So increases by a factor of K. So this question is generally asked in boards also a lot. What happens if I have inserted a dielectric in a capacitor which is connected to a battery? Okay. So first thing, if it is connected to a battery, the delta V, the potential difference across the plates does not change. The capacitance, of course, will increase by a factor of K. All right. Yes, yes. So here your studies never take a break. All right. You won't feel helpless. Okay, where do I study? How do I study? You can continue your studies. Similarly, if the capacitance has changed and if the V has remained the same, what happens to the Q? The Q also increases. So the capacitor will draw extra charge from the battery. So next, Q on the capacitors, on the capacitor also increases by a factor of K. And finally, what do you think will happen to the energy stored? The energy will also increase by a factor of K. Why? Because the energy is half CV square. V remains the same. C becomes K times higher. So this will become, so energy stored increases by a factor of K. So it becomes K times the original energy stored. So please remember these four things about this case. Okay. As I said, this is asked in your boards and in your school examinations a lot. You should know this. You will have this kind of direct question. All right. So please be really, really familiar with this. So if a capacitor is charged and the battery is still connected, and then a dielectric of dielectric constant K is inserted. So this is what happens then. So you had a capacitor which was charged, it was still connected to the battery, and you inserted a dielectric of dielectric constant K. In that case, the delta V across the plates remains the same, equal to V, which is the potential difference of the battery. Alright. The capacitance obviously increases by a factor of K. We already know that if the dielectric is inserted, the capacitance would increase. The charge in this case will increase. Why? There is a battery. So the plates will draw extra charges from the battery and increase their charges. Now, since the capacitance has increased, the potential difference remains the same. So the net energy stored would also increase by a factor of k. Alright, so please remember this. Next, what happens if the capacitor is charged and battery is disconnected? And then a dielectric is inserted. Now what happens? So what do you think will happen if imagine if you charge this, if you charge this with a battery, it got some Q charge, it got some V potential. Now if you disconnected this, it'll still have a Q charge. And now when you are inserting a dielectric, you will realize that the charge now cannot change. Alright, why? Because this is isolated plates of the capacitor. So both the plates of the capacitor are isolated. They are not in contact with anybody anymore. So they cannot transfer any charges to or from any object. Alright. So in such a case, the charge on the capacitor never changes. Alright. So charge never changes. C, we know will change. So what will change? In this case, the V changes. So firstly, you need to remember Q does not change in this case. So please remember, if the battery was still connected, then V does not change. If the battery is disconnected, then Q does not change. Alright, what happens next? V. Now what? Okay, so let's just first immediately talk about C. So C obviously will increase by a factor of K. C increases by a factor of K. Alright. So this is plain and simple. If you are inserting the dielectric, C will always increase. Okay, so there is no doubt about that. Now, if Q remains unchanged and if C increases by a factor of K, what happens to V? Now you will realize that V was nothing but Q over C. So which means the potential difference between the two plates would decrease. Remember, I told you this also, that when you're inserting a dielectric, for the same charges, what that is doing is that will reduce the potential difference across the plates. Why? Because it's weakening the electric field. Alright, it is weakening this electric field. This electric field would be higher, this electric field would get weakened when you insert the dielectric. So as a result, your delta V, potential difference, delta V across the plates would reduce by a factor of K. Alright, so please remember this. Now what happens to energy? What happens to energy? Energy would get reduced by a factor of K again. Why? Energy is Q square over C. Q remains unchanged, C has increased by a factor of K. So the energy stored would decrease by a factor of K. Alright. Energy stored decreases by a factor of K. Alright, so please remember these. Alright, these two situations are very commonly asked, that a capacitor was charged and then it was still connected to a battery and then a dielectric is inserted, or it was disconnected from a battery and then a dielectric is inserted, and how are things changing. Alright, so this, trust me, is very, very important for your school examinations, also for your boards, for your mains. Alright, so in the past years when I was teaching, I was also teaching in a school tie-up program by a very reputed institute. So there I have taught everything. I used to take classes in school for physics. So there we were supposed to take care of the boards, take care of mains, take care of advanced. So I can tell you important bits about every part. Alright. So this is important as far as your school and boards are concerned, as well as mains. Alright. Now, next, I wanted to start the discussion with RC circuits. Okay, I think we still have around 10 minutes left. So, what are RC circuits? RC circuits are nothing but circuits which contain both resistors and capacitors. All right. Now, we see earlier when the circuits that we were talking about, earlier what we were saying, you have a capacitor. If you want to charge it, you connect it to a battery. It gets charged instantaneously. All right. There was still energy that was getting dissipated. If you remember, work done by battery was VQ, and work and energy stored in capacitor was 1 by 2 VQ. So I had asked you, where do you think this energy is going? So did anybody try and find out where this energy is going? Where half the energy is going? I mean, it's not a small amount of energy that goes missing. Half the energy, half the work done by the battery goes missing. So I would like you guys to find out about this, that how can energy disappear here when there are no resistances? Okay. I mean, forget about practical case. I'm talking about a theoretical case. A theoretical case in which every wire is perfectly resistanceless. Where can half the energy go in that case? Now here I would know. Here I would know. Whenever current is flowing, this guy will dissipate some energy in form of heat. Alright, resistors will generate heat. So here I have no problem explaining. But how do I explain the loss of energy here? What is it that is causing the loss of energy? There is nothing that should cause loss of energy. Alright. So you try and think about it, you try and get an answer, and maybe you can write in the comments, or maybe we can you can come live in the next class and we can discuss this in the next class. Alright. So let me just quickly tell you how the essence is. We won't start the analysis of RC circuits today. Okay, I think I will want to start this day after tomorrow only. Alright, in a fresh session, because we have what, five minutes left for today's session, and I don't want to start an analysis which I can't finish today. So analysis of all these circuits, whether it is RC circuit and whether it is any kind of circuit having any kind of elements, batteries, 5 batteries, 6 capacitors, 7 resistors, multiple resistors, multiple capacitors, multiple batteries, and maybe other circuit elements also. Something called an inductor. We will study about that. Any kind of circuit can always be analyzed with the help of KCL and KVL. Alright. So we will talk about two kinds of RC circuits in the next class. One, charging. When the capacitor is getting charged, another when the capacitor is getting discharged. Alright. So I wanted to show you the entire derivation. So obviously I wanted to take my time with this. So that is why I don't want to start with this right now. So we'll take this up. We will take this up in the next class. So let me wrap it up for today right here only. Alright. So before I leave you guys, let me remind you that you can get your Unacademy subscriptions using following these simple steps. You go to the plus section, you select your goal as IIT JEE, alright, and you click on that get subscription button. Alright, so I think the Unacademy JEE English team will also be most likely starting their courses this month. I think Rahul Kaushik sir has already started a course, and I think me and Abhinav sir will be following soon. I think from around 15th of September. So if you're looking to register for courses on Unacademy in English, then look out. We will be starting the courses very, very soon. All right. Now please remember that these prices are valid only till 10th. So please remember to get your subscriptions. If you haven't gotten your subscriptions as fast as possible, at these prices, you cannot be missing out the subscription. And from 10th onwards, so that gives you just 1 week, the prices are going to become more than 1.5 times. Alright, so please, if you, especially the cheapest price would be in the 2-year subscription price. So if you haven't gotten your subscriptions yet, please go ahead and get them. See, this is already 1,500 rupees a month. This is way less than what people are paying for their tuitions. and you're getting a 10% off on this if you're using this code RD Live. So remember to use this code RD Live. You will get 10% off. All right. So in that 10% off, this subscription fees comes out to be 1350 a month. All right. 1350 a month is absolutely nothing. All right. So please go and get your Unacademy subscriptions before the prices hike. Otherwise, for this same subscription, you will have to pay about 20,000 extra. So please remember this. If you do not get these subscriptions till 10th of September, after 10th, you will have to pay 20,000 extra for this subscription. All right. So the cost is going to change from 36,000 to 56,000. So save up on that money, get your subscriptions as soon as possible. And as I said, at these costs, it's a must-have. Plus, you also have the option of converting this into no-cost EMIs on your debit card and credit card payments. All right, so you can convert these payments into no-cost EMIs, which means you won't be charged any extra interest. You can continue paying this. The bank will provide you that facility. To the bank, you can continue paying 1350 a month, and 1350 a month, I don't think will make a huge hit for anybody. Right? That is why Unacademy had kept these prices so low that every student can afford this. All right, so please go ahead, get these subscriptions, and make the best of this. Next, if you like today's video, if you think I taught you new things, then press the like button and share it with your friends. Again, as I keep saying, see, Unacademy's aim is to provide quality education to as many students as possible. So yes, of course, Unacademy has to charge you a certain fees in order to maintain, everything, the platform, the salaries of teachers, the salary of any technical staff, everything. So they have to charge a fee. So that is why you have a subscription fee. But Unacademy wants, even if somebody cannot afford those subscription fees, then also they should get content for free. This is what this is. So in case you can't afford the subscription fee, even that is more for you, then don't worry. We still got you covered. All right. We still have your backs. All right. So it's just that obviously the amount of practice and the amount of teaching here would not be as rigorous as in the regular course, because there you would have more interaction time, more face time, obviously, and more regular classes. Here you see people come on different days. Most of the people like watching this, offline. There, all that won't happen. Every lecture would be happening online. You will have to attend it online. So that will, trust me, be much more effective than these lectures. It's not like you can't clear your JEE by watching these lectures. Trust me, the content I'm discussing is exactly the same that I would teach in my offline coachings also, which would be good for advanced also. All right. Alternating current, please. Okay, one shot. Okay, so but before alternating current theory part, trust me, Sabresh, nobody is interested in theory parts in one shots. I've tried it. People start complaining. People say we want questions, we want question practice. We don't want theory. All right. So maybe I can, as I said, I was planning on taking some special sessions on magnetism, and then EMI and AC. Maybe I can take that. There I can discuss theory. All right. If I announce as a one shot session, trust me, people expect small amount of theory, more of questions. So that is the problem. All right. So as I said, if you can't afford this subscription also, then make sure that you are sharing it with more and more of your friends, so that at least everybody can get access to this free content. And trust me, this free content is a high quality content. I am covering every topic, keeping in mind that this should take care of your JEE Advanced also. All right. Now, please don't forget to press the bell icon to get notifications of all the lectures, and also the PDF of all the slides used in today's lecture would be available for download later. All right. Next, you can join us on the Telegram app using the link shown here. And finally, before I leave you, this is my code. So please use this code in getting your Unacademy subscriptions and get 10% off, and get your subscriptions before 10th. Get your subscriptions before 10th, because as I said, after 10th the fees is going to get hiked. All right. So don't go and complain later. Nobody told us. So Unacademy is announcing it. We are announcing. Teachers are announcing it in every class. We have given you 10 days. We have been announcing it since the last 3 days. So make sure you're getting your subscriptions before 10th. Alright, because for a 2-year subscription, you will end up saving around 20,000. So get your subscriptions as soon as possible. And I'll see you day after tomorrow where we will carry forward this discussion. Till then, you guys keep studying and keep practicing. Take care and bye-bye.